Okay. Today we are going to discuss problem of points on side views. Okay. So in this problem, so we will be dealing with the side views here. So we will go with the question. A point P is lying. P is 30 mm in front of VP, 40 mm above HP, and 50 mm front from RPP. Okay. So in this problem, so as we have know, so it involves three concepts. First, to identify the quadrant. So in front of VP, above HP means it is our first quadrant. So for the first quadrant, we know the notations. So VP, HP, XY. That means first we are going to draw the this first quadrant, top view and front view. Okay. Okay. So we know that 30 mm in front of VP means it is in front of VP means it is top view. So top view it is drawn in the HP plane. So 30 means 3 boxes, and you put a point. So that is here the top view. Similarly, 40 mm above HP. So 40 mm above HP means it is our front view. It is 4 boxes. It is P dash. So now we'll show with the dimensions. This is 40 mm and this is 30 mm. Now you can see this 50 mm from RPP. This is what the side view. So where it is exactly means in the quadrant. You can see this. So this is our HP plane and this is vertical plane and this is our RPP, right profile plane. So this right profile plane it is adjacent to the vertical plane. Okay. So in this problem he is mentioning that a point P is 30 mm in front of VP and 40 mm above HP and 50 mm from the RPP. So this it will be there adjacent to the vertical plane. Okay, when it is drawn in the orthographic, so it will be like this. Okay, so front view, top view, this front view connected with the side view. Okay, so that means for this RPP we will be drawing another x1 y1 line at a distance of 50 mm. Okay, now to draw this side view with the top view we will be using 45-degree angle line. Okay, so you just follow the procedure. Okay, now from this projection point we have to consider a distance of 50, that is 5 boxes. Keeping this distance of 5 boxes, here we are going to draw x1 y1 because it is 50 mm from RPP. So this is x1 y1 RPP, right profile plane. Okay, now we know that so side view will be there adjacent to this front view. So we draw a straight line. After this we know that we have to draw an 45-degree angle line here. Okay, in order to connect the top view with the side view. So that is 0, 10, 20, 30, 40, 45. So mark a point, then draw a straight line. This is your angle line, that is 45-degree angle line. Now from this top view, so you will be drawing a straight line until it touches the 45-degree line. Then we project upward. Okay, so where these two lines are intersecting, so this point is our side view. Okay, this is what the and we can show the direction of the projection line. Okay, so this is what the side view. So today in this problem we construct a pentagonal pyramid with respect to slant triangular face. So the same thing can be demonstrated using SolidIt software here. I'm constructing a pentagon using polygon by center here. Draw the perpendicular bisectors here. After writing down the notations, we should draw the projection lines here. Okay, copy down this and using a move command, and then slide along the XY line, and then select these heads. So however it is there in the solution book, I'm following the same procedure here. Now project downward to complete the second position top view here. After drawing the projection lines, write the notations. And mark the notations. Okay, after marking down the notations, the concept here it is same. First you have to draw an outer boundary line, then the visible edges in the visible faces, and then finally the hidden edges in the hidden faces. Okay, so first I'm constructing an outer boundary line. Here from the top face, so pentagon it is visible, that's why continuous, and A dash to also continuous U. Okay, but the triangular face D, O and C not visible, that is written with the dashed line. And axis you have to show. Now draw an angle line for 45 degree, that is minus 45. Select the second position diagram using move command and place it with respect to the axis. So project the lines to complete the final position. Combination of cylinder and rectangular block. Okay, so to construct here, first we need to take one horizontal line as a reference. From this reference point, I'll draw one line, that is line with an angle of 30 degree. So here I'll take 60 mm. Okay, and angle will take 30 degree because in isometric we should use angle 30 degree. Okay, first I'll be constructing an rectangular block. Okay, so here the rectangle block having base sides 30 mm 30 degree and vertical edge 60 mm, angle is 90 degree. Again length is 30, angle is minus 150, and then vertically downward is joined with a length of 60 mm. Okay, now we have to give the width here. So width of 30 mm at an angle of 150 degree. Okay, so the same line I'm going to transfer it using move command, creates a copy, then place it like this, so it will reduce your effort. Okay, now complete it, so the rectangle block will be over. Okay, now we have to draw the cylinder. So cylinder, it is there exactly at the center of the block, so the total length it is 60, means we need to subtract by 15 mm. So just see, so watch the video till the end, you can understand. So vertically downward by 15 mm, I'm coming downward 15, 90 degree, and then 30 mm, then angle of 150 again here. Now the length required for the box, it is 30. Okay, again horizontally. So this is the box we require to construct the ellipse here. So from this corner point to the midpoint. Okay, again from this corner point to midpoint. Okay, from this corner point to midpoint. Okay, from the corner point to the midpoint, you can select the line. So now using for arc by center method, that is using arc by center method. So here we will be constructing an arc here to construct the ellipse, taking this length, draw an arc. Same way from here to here, take this length, draw an arc. Now for the third point, okay, take this as a reference point, taking this line, draw an arc. Okay, and same way here also, take this length and draw an arc. So we have completed an ellipse here. Same way you need to construct another ellipse at a distance of 60 mm. For that, as a reference, I'll be considering a length of 60 mm, and then another box of ellipse I'll construct. Okay, for a reference I'll be taking this length. So length of 60, angle minus 150. Because we should be extruding at a distance of 60 mm, right? That's why I'm considering this length of 60, angle minus 150. Okay, from all the four corners of the box I'll be extending the same length, 60 mm, and angle is minus 150. Okay, okay, now here we got the endpoints. Here we need to construct a box here. Okay, subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. So it is important, guys, you should go through all these model question paper. There may be chance you can get the same questions for the exam, because the question paper, it is coming from the VTU. So make sure you go through all the problems, because we don't know which problems may be coming for the exam. Okay, in each model we have 50 different questions. Okay, just go through my videos wherein I have explained the problems with all concept with less time. Okay, guys, make use of the videos, and during the exam time it is very helpful that you can revise this subject using my videos. Okay, because you may be forgetting all the concept, because the practical exam, it is there after 1 month. Okay, so draw a diagonal line. Okay, now join from this end to this end. Again, join from this end to this end. Okay, so now we need to make these lines as thick lines. Okay, so rectangular block also I'll make thick by selecting all the edges. Thank you all. Thank you for watching my video. Subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. This, okay. First we draw an parallel line here. After that we draw one vertical line. Okay, vertical line we draw here. So vertical line, after drawing it, so it is hexagonal prism, so that means it has to be so set with the using offset command. So I'm going to construct it. You can see this is cut, so that means the front and top view will be given in the question. So we need to draw only the development for this. Okay, so vertical line drawn. Now using offset command, I'll be offsetting this vertical line for a distance of 20 mm. There are total 6 faces I'll consider here. Okay, 6 faces we are considering it. You can mention the naming for it, each of these vertical edges. Okay, that is capital A, capital B, capital C, capital D, capital E, capital F. So mention EF and A, and now we have to mention these cut points here. So cut points, that is with respect to the section plane, we are mentioning 1, 2, 3, 4 here. So we have to draw an horizontal line. Say from this end, you can draw an horizontal line. So that is our 1. So we get it on the vertical edge here. That is 1 and 1. Okay. Same way, so the projection of horizontal line from 2 till B. Okay, that is your point number 2. Okay, now projecting the point number 3 horizontally till the vertical edge C here. Okay, now point number 4 exactly falling on the corner point of the vertical edge D here. So we can mention that is 4 here. And point number 5, it is the extension of the point number 3. So we have to extend that horizontal line from that point 3 till the vertical edge G here. So that is your point number 5. Okay, now the same way we have extended the 2 to get the 6 here. So actually at the vertical edge it has to be 1. So you can change it. So now I am rewriting it correctly. So that is our point number 5. Okay, and that is point number 6. And now here we are getting the point number 1 here. Okay, now the same way for the bottom faces also we have to draw an horizontal line here. Okay, you can see that the point number 7 on the vertical edge. It is having on the B here. You can see that. Okay, So point number 7 we are getting on a vertical edge B here. So that is your point number 7. And point number 8 you get it on the vertical edge of C here. It is falling on the same vertical edge C. Okay. And point number 9 is on the same vertical line 1 here. So we can draw an horizontal line, or we can show it on the horizontal line of 1. So I'll be drawing it so that it will be convenient, that will not get confused here. Okay, that is point number 9. And the same way we have to mention the point number 10. Point number 10 falling on the vertical edge E here. Okay. Point number 11 we get it on a vertical edge 7 here. So just I am projecting using extend to next command. I am getting that point. Okay. So that is your point number 10 here. And using extend to next we get the point number 11 also. Okay, that is your point number 11. Okay, so now we can join all these points. All these points with a straight line. You can try to connect it. Okay. You can zoom in and connect. Okay, zoom in and get the exact point here. For that you can zoom. Okay, zoom in, zoom out. You'll get the exact points here. Okay, now it is connected. You can see that. Now the only the cutted part we have to make it dark, then the other part we have to make it thin. So for that we will be using split command. By selecting it we are going to make those lines as thin lines here. Okay, using the split command we can show the remaining part in a thin lines. So you can select those lines and make it thin here. So you can subscribe for the channel and hit on the bell icon for the latest notification of this engineering visualization subject, and share it to the maximum students so that they can be benefited. Hit the like button and share it to the maximum students so that they can be benefited. So by selecting it, we are making this as a thin line. Okay, so you can see that this completes the problem here.